Okay, great. Our next speaker is Rich Lucas. Rich Lucas is MSU Foundation Professor of Psychology at Michigan State University. He received his PhD in psychology from the University of Illinois at Champaign-Urbana. His research focuses on the causes and consequences of subjective well-being. In particular, he studies the associations between personality and well-being, and he examines the extent to which people adapt to major life events and changes in life circumstances. Dr. Lucas is also interested in measurement, and he conducts studies designed to evaluate the psychometric properties of personality and well-being measures. He's also interested in replicability and has been involved in efforts to promote replication and improve research practices. He's a co-author of the book Well-Being for Public Policy and a co-editor of the books Secondary Data Analysis and Stability of Happiness. He has served as associate editor for the Journal of Personality and Social Psychology, and he is currently editor-in-chief of the Journal of Research and Personality.
All right, thanks. So I'm going to be talking about two what I think are simple steps for improving social science. And before I begin, I did want to acknowledge the fact that in terms of this idea that these are simple steps, I acknowledge that people are going to disagree about whether or not the problems that we're facing really are simple. And so I think that when we talk about doing replications, and specifically direct replications, or trying to increase the power of our studies by having larger sample sizes, that this is a challenge in terms of finding the resources to do these things. But I think when I look at the two approaches that I'm going to be talking about in terms of trying to improve some of the problems that we've identified, that Garrett has talked about, that the ideas behind these are really straightforward and simple, and it's kind of interesting to think about why they haven't been actually employed more frequently. So I'll focus specifically on doing close or direct replications and improving the power of our studies. So I've been asked to do a number of these types of talks. I do a lot of, in addition to the substantive work that I do, I also do work trying to think about how replications work and trying to replicate some of our studies in the field. And so when I'm asked to give a talk about this, I'm kind of put in a strange position because I think that we all think of replication as being absolutely essential to science, that when we build on a finding, we assume that that finding can be replicated, that if we use the same procedures that were originally used, that we will get the same result. We use that to develop interventions that build on the finding. We use that to expand our theories and extend our theories, assuming that we make some changes that then test additional hypotheses. And in fact, the whole problem that we're dealing with has been called this reproducibility crisis, which suggests that there is some problem in our ability to replicate findings from the past. Yet at the same time, when we look at the attempts to actually replicate findings, they're extremely rare. And so we are in this position of trying to defend this basic process of doing replications that seem to not happen quite a bit. So I think we all can start with this idea that replication is essential for science, that we have to build on solid findings that we know can replicate. But we know also that replication has a number of additional benefits in addition to that. So I think one of the things, so what I'll try to do is talk about some of the benefits, some of the objections, and some of the things that we can think about in trying to address those objections. So in addition to just being a fundamental part of science, replications also constrain researcher degrees of freedom. So there's a number of strategies for addressing the issues that Garrett talked about. In some ways, replications are a nice way to apply some of these basic principles in a way that actually allows us to use this in our own work. So we do a finding, we explore our data, we get some interesting finding. We didn't pre-register our results. We worry that questionable research practices affect our interpretation of the data. Let's replicate that study, do it exactly the same way we did it before to make sure that we are not capitalizing on chance in some of those things. Or if we want to go back to old findings where we know they didn't pre-register and we know that they didn't, that they could have been influenced by these things, this gives us a chance to assess whether or not we believe in those findings by now doing a direct replication of those earlier findings in the same way, and it prevents us from falling prey to some of these problems that we just heard about. Replications themselves, I think, also promote these broader goals of transparency and openness. I think that as someone who, was a part of psychology where a lot of these things were not, data sharing and these sorts of things were not the norms for a very long period of time and still really aren't, there's nothing that pushes you towards being a better archiver of your data than someone asking you for it after the fact. And what this makes you think about is how I should have done this differently when I was dealing with my data so that it would make it easy for me to actually give those data to someone else. Doing replications is another way of doing this, because as you start to realize that other people are going to want to replicate your work, you're going to want to do your own replications, you have to keep better track of the processes that you're doing, using the analyses you're conducting, so all these things can be presented to other people so that they can replicate your work. So I think that getting in the habit of doing replications promotes these goals. Replications also address generalizability. If something fails to replicate, it may not be that the original finding was wrong, it just means that it might be more limited in generalizability than we had initially realized, and that is important information as well. So what happens when we start doing replications? Well, as probably most of you are aware, things haven't looked so good in a lot of these initial attempts. So probably the most famous example of this is the reproducibility project in psychology, organized by Brian Nozick and the Center for Open Science. And what they did is they got a team of investigators together to try to replicate 100 studies in top journals in psychology. And the results, for many people, were very disappointing. So what this graph shows you are the original effect size on the x-axis and the replication effect sizes on the y-axis. The pink ones are ones that did not replicate, or at least were not significant, and the green ones are the ones that did replicate or were significant in the same direction as the original study. And the headline result from this type of study is that only about 36% of the original studies replicated using that criteria, which seems pretty disappointing. Now again, there are disagreements about how we should interpret these results, but I think that they're part of a broader pattern, at least within psychology, when we try to do these systematic attempts at replicating previous findings, that we are somewhat disappointed with the results, and things sometimes don't look so good. Now, in addressing these types of issues, I think that a lot of us think that this is a call to the field, that we have to start improving things, we need to do more replications, we have to start to consider why these things aren't replicating. Yet at the same time, I think there is a lot of pushback to interpreting replication studies and understanding what we can get from doing replications. And so I'm going to give you two sets of arguments against replications. The first of these I don't think are great arguments, but I think that they're out there and anyone doing replications has to deal with them. And the second set I'll get to, I think, are ones we should take a little more seriously. So I'll quickly go through these first arguments that I've heard why we shouldn't do them or why we shouldn't necessarily take them seriously. First is the idea that replications are boring. And so we do hear this a lot, that people don't want to hear about the replications or something they're not interested in. We want to discover new things. And so it's just not that much fun to do replications or to read about them. There's also this additional aspect as someone who has tried to replicate other people's findings and has been, and these findings have been discussed in social media, is that there's an idea that people who do replications, who take someone's finding that's from a theory that they're not even interested in or it's not even their theory, that they're somehow out to get the authors of the original research, or worse, that they're not good enough scientists on their own to come up with a new idea, so what they do is simply replicate someone else's work and try to take them down in that way. Again, it's something that I think people who do this work have to deal with. There's another flip side of this, is that it's actually bad for the people that are doing science if we actually try to replicate someone's specific finding, that it's somehow bad for their reputation if we find that their result doesn't replicate, which of course the result is not about the person. We want to know whether this finding is true, but I think that a lot of people are hesitant to actually attempt replication studies for these reasons. And then there are concerns about what types of studies will get replicated, and I think that this is an issue that did come up with the critics of the reproducibility project, that actually in attempting to more systematically do replications, that only a subset of the types of studies that we do will attempt to be replicated, and specifically the easy ones, and also give us a misleading idea about the reproducibility of the findings in our fields. And finally, the last one I've heard more recently is that, that I think that sometimes people interpret a push for replication as meaning that whether a finding replicates or not is the only thing that we should consider. And I've heard the suggestion that successful replications of bad studies actually are bad because they make people overconfident of a result, as if the only criteria we're now interested in is the replicability, and we therefore don't evaluate whether the study was a good study in the first place. And of course, people who are suggesting that we do more replications are not making the argument that that's the only criterion we evaluate. Now, in addition to those arguments, I think that there are some that are better, at least I have a question mark as to whether they're better, because they're more about how this affects science as a whole. And so, for instance, one of the arguments that I think people make frequently is they waste resources that could be used for discovery. So clearly, if we as a field in psychology, instead of actually conducting new studies, all we did is replicate our greatest hits over and over again, the field would not progress, and that would be bad for science. So clearly there is some allocation of resources that needs to happen to deal with this. And there are arguments about how many resources we should be putting into each of these. I've also heard a lot of complaints about the impossibility of doing exact replications, and specifically when a replication is published and it fails to find the same result as the original study. A lot of times people will argue back that there were subtle differences in the context that could change results, that the replicators lacked the expertise, and that prevented the successful replication, and this could lead to people prematurely dismissing valid findings. And again, I think that both of these are reasonable points that we should consider every time we try to replicate findings. I think the problem that we've seen is that a lot of times these are thrown out as post hoc explanations for why a finding did not replicate without actually testing any of these things. And I think it is possible to actually get empirical evidence, as I'll talk about, for these. And then finally, as a culture, I think that there are fewer rewards for doing replications. And so there is a legitimate discussion that we have to have about how we reward people for doing replications and getting, in terms of promotion and tenure decisions and hiring decisions, how we as a field can encourage these sorts of things, given people's evaluation of them right now. So I think one of the biggest responses is that we can actually just collect data on these sorts of things. And the more we do replications, the more information we have that actually specifically addresses the issues that people have raised in objection to doing replications. So for instance, from the reproducibility project, we start to get a sense about the rates of replication. Is this a problem that we should be devoting resources to? If we are disappointed with 36% of the findings replicating, maybe we should be putting more resources towards replication. It helps us decide on that allocation of resources by doing these studies and knowing whether or not there's a problem. Other projects like the Many Labs project, if you haven't heard about this, it's where they recruit a large number of labs to replicate a set of studies, and then you can see whether or not the results vary across different labs. And so what those studies typically tend to show, there's multiple of these now and they're ongoing. Some effects are easily replicated regardless of the lab, so this addresses the issue of whether expertise is an important factor. They can actually manipulate certain contextual features to see whether context really matters for these sorts of things. We basically have the ability to get empirical evidence about these meta-scientific questions about the way that we do replications and the types of factors that can be used to argue against the interpretation of failed replication. So all these types of things I think are important. So here's the results from one of the Many Labs projects. And again, so what you do is you have a number of different studies. Each line is a study that they tried to replicate. You had the blue dots are the effect sizes from the original study, and then the other dots are the effect sizes for the replication studies. And what you find is that, and they did this separately for US versus international studies, one of these big contextual moderators that people have often talked about as being an issue. And so what you can do is you can see whether some labs are better on average than getting a significant result, and whether international studies versus the US samples lead to different types of results, whether we can replicate things in general. And what you find is that certain effects replicate really well and actually get even bigger effect sizes in the original studies. Other ones don't replicate very well at all, and it's very consistent. So we can again see the effect of these moderators, see the variability across labs. We get data we can use to answer those questions. Okay, the other thing that I often hear about replications is a claim that when we do a replication and we fail to replicate, that we have somehow overruled the finding, that we now have shown that it's wrong. I've never actually heard very rarely, in almost every case, people who do replications and fail to find it are very, very cautious in the interpretations that they come to in terms of those results. They often bring up the same objections that I talked about before in terms of potential contextual moderators. And even in the reproducibility project, they're extremely careful in that way. So few people who do replications would claim that a single failed replication means that the original finding is wrong. But at the same time, the temporal order of these studies does not privilege the original finding either. And I think that the way that the field works right now is that oftentimes having that one finding where it's difficult to even question, once it's out there, it's difficult to get attention on the findings that might not support that. And so I think that we have to remember that that temporal order does not privilege the original either. So replication is this critical component of scientific investigations, and now that we're getting more data about whether or not this is a problem, I think it's especially important to actually do more of these studies, to do more of the replications to see where these effects are. Okay, The second step then to move forward has to do with ensuring adequate power. This is actually, again, a very simple idea that has not been considered enough. So statistical power is simply the probability that a test correctly rejects the null hypothesis when the alternative hypothesis is true. So if you make a prediction, you get a significant, it's the likelihood of you getting your significant result. So power is a function both of the effect size and the sample size of our study. Bigger effects, you have higher power. Larger sample sizes with the same effect size, more power. And at least in psychology, when people have looked at this, most analyses suggest that psychological studies are dramatically underpowered. And I think and we've known this for decades, I think the reason why we've ignored this is that there's this misconception that power is not an issue when one finds a significant result. So if we're worried about not finding the significant result, once I find the significant result, power must not be a problem for me or for the field, and that's why we don't pay attention to the underpowered studies in our field. But to understand why this is a problem, we'll go through one example here with an effect size that we can see. So on average, men are taller than women. This effect size is a large effect size. It's a D of 1.72, and from one study that looked at this. And so what this means, if we want to do an adequately powered study where we take a sample of men and compare them to a sample of women, we need to take find about 10 men and 10 women to be pretty sure, 95% power, that we are going to statistically detect a statistically significant difference between the two. But let's think that instead of about what happens if we actually find 4 men and 4 women instead of 10 of each. And in this case, even though we know that that difference is real, even though we know what the actual effect size is, we're only going to find a significant result half the time. Now, this is a problem. This is a problem if we invest resources in a study and we know we're only going to get a significant result half the time, so it's a waste of resources. But in addition, it starts to tell us about other problems that might come up. One of these, for instance, let's say you were teaching a statistics class. As a class project, you had your students go out and test an obvious difference. So you tell them to get a sample of men and a sample of women, and you tell each student to sample 4 men and 4 women and get their heights, and calculate it, do a t-test, and you should find that men are higher than women. And what happens if now these students come back and every single student in your class, 100% of them, found a significant effect? Something must be wrong, because half of them should not have been able to find that effect, yet they all come back to you with their happy faces saying, I found my significant effect. This is evidence, when we have things like this where you're getting too many significant effects, this is evidence for p-hacking and these other types of things. So again, if, for instance, we can even think about this within a single study, let's say we run 4 studies, each with 50% power. The probability of us getting 4 significant results is just 0.06, very unlikely. And so the conclusion from these studies is that when we get these types of results, it suggests that there's some sort of p-hacking or file drawer problem going on. So these lead to other problems. So what we know, we can do simulation studies to show that running many small sample studies leads to more significant results, but more of them are false positives. The simulation studies are really clear on that. These leads to overestimate of effect sizes, and also there's some evidence that it might be easier to p-hack when the sample sizes are small. So even if we are finding significant results, the underpowered nature of our studies is really problematic. So I think in looking back on all of these issues, we know a lot about the reasons that things can go wrong. So we have the motivation. People get rewarded for finding new things, not for replicating old things. We have a psychological mechanism that explains why we do this. We have confirmation bias. We know about our selective focus on things that support our views. We know the behaviors that go into p-hacking, and we have surveys of these that Garrett talked about that show that people actually admit to doing these things. We have evidence of publication bias. We have too many significant findings out there in our literature. We know that there are few replications reported, and now that we're starting to do these replications, we have a number of high-profile failed replications. We have the estimates from the Reproducibility Project. We're starting to get registered reports where multiple people try to replicate the same finding. We have the many lab studies. All of these things are pointing to a problem. Now, when we start talking about increasing power and increasing replication as a solution to some of these problems, oftentimes people will argue without empirical evidence against one of these steps. And I think that as we take those arguments into account, we have to think about the broader pattern of results that we found. And I think that if one wants to argue that we don't need replications, we don't need to increase our power, in addition to saying how context might matter, and this is why your replication didn't work, or expertise might matter, what those people need to do, I think, is to do more, to do their own simulations, find their own empirical evidence that now contradicts a lot of the broad range of evidence that we have that these things are, that make a difference. So I'll stop there.